So we've learned that solutes can dissolve in solvents to make solutions. And we learned about the dissolving process. Well, some solutes are better at dissolving in solvents than other solutes. And the measure of how good a solute is at dissolving is called its solubility. Okay? So its solubility is how good a substance is at dissolving. And there's three different things that we learned that we can change if we want to increase or decrease the solubility of a solute. The first one is the surface area of the solute. So imagine you have a sugar cube here that you drop into a cup of water, and here you take the same sugar cube and you crush it up and you drop it into the block of water. The crushed up block has more surface area, meaning that there's more places for solvent molecules to come in and collide with the solute than there are when it's just a cube. Since there's more surface area, there's more places for collisions, so solutes with higher surface area have increased solubility. They are better at dissolving than substances with low surface area. Temperature can also affect how good a solute is at dissolving in a solvent. So let's say we take a sugar cube in this cup, a sugar cube in this cup. They're the same size, but one of the cups is at 50 degrees Celsius and the other is at 100 degrees Celsius. Well, the cup that's at 100 degrees Celsius is going to have an increased solubility. Higher temperature equals higher solubility because of the same logic. The molecules are able to collide more often. The solvent is able to collide with the solute, overcome the electrostatic attraction within the solute, and break it down and break it apart. This is because when the temperature goes up, molecules move faster, so when they move faster, they collide more and cause dissolving to happen faster. Pressure can also affect the solubility of a solute, mostly when we just refer to gases. Okay, so pressure only affects the solubility of gases. So for example, on the right, we have a beaker with a lid that we can push down. And the red dots represent solute molecules, gas molecules. The blue is the solvent. So when we push this, lever down, when we shrink, this volume, okay, the pressure of the gas is going up. Since the pressure is going up, okay, more molecules are going to be pushed down into the solvent. So since more solute is getting pushed into the solvent, we would say that the solubility has gone up because there's more solute dissolved. So for all three of these, if you increase pressure, if you increase surface area, if you increase temperature, solubility will increase. And it's all because of the number of collisions. There are more collisions between the solute and the solvent occurring. So go ahead, try this question by yourself with that knowledge of solubility. Press pause, and when you're ready to see the answer, press play, and we'll go over it. So, which of the following would dissolve the fastest? Ground up coffee beans in hot water, whole coffee beans in hot water, ground up coffee beans in cold water, or whole coffee beans in hot water? Okay? Well, we know that temperature affects surface area. We want temperature to be high. And we know that surface area needs to be high too, for both of those to affect solubility. So we got to find the answer that has the highest temperature and the highest surface area. Well, ground up always has, it's like a powder, that has more surface area, so we can automatically eliminate B and D, because those are whole coffee beans. Then we're just left with hot water or cold water. Well, hot water has a higher temperature, so A would be the correct answer. A really good explanation that I would see would be something that says A would dissolve the fastest because the coffee beans have the greatest surface area and the temperature of the water is the hottest, so the number of collisions between solute and solvent will increase, leading to higher solubility and a faster dissolving. So go ahead and log on to Exit Ticket on your iPod or Chromebook to answer the exit ticket questions for this learning target 5.3.